What's going on, everyone, and welcome to episode 1 of Tool of the Week. My name is Zach Holcomb with Additive America, joined by Richard Savage of Savage Automation. We thought we'd put together this cool little mini-series for you called Tool of the Week because why not? It's a really awesome name. And we're talking about end-of-arm tooling. So, Richard, you're a fan of all of this stuff. Explain to the folks at home, what is an EOAT?
Yeah, so EOAT actually is the incorrect pronunciation. Drives me nuts. EOAT, right? Stands for end of arm tool. So end of arm tool, it goes by actually a ton of different names, right? As anything in the industry, end effector, head tool, end of arm. But basically, this is the interface between any robot and what it's actually doing. So that can be as simple as like a suction cup for just picking one thing up, or as complex as maybe like a surgical device on the end of a robot doing remote surgery, or anything in between. Real common. This is a very common. What does an end of arm look like? This is a horrible end of arm. It just makes me cringe. But you can see we've got suction cups for picking up parts, different type of part. We've got this mess of hoses going everywhere. This is kind of the classic manufacturing environment end of arm tool.
It's like a lot of 80-20 in tubing, right?
Yeah, right. 80-20 in tubing. So this aluminum extrusion, it's got a couple of things I really hate, Zach. It's super heavy, number one, when it doesn't need to be. Mm-hmm. And it has all these little framing pieces on here that are just kind of bolted into the channel. And the thing sometimes I think people, they like that because they're like, look how I can adjust this thing all over the place. But the problem is with a robot, you really don't want things to be flexible. You want something that's going to do the same exact thing every time. You know, tech number one's going to come over and adjust this, and he's going to get it all set and run the process. And when the job's done, they're going to take it off the robot and put another one on. When you come back to this, that tech's going to have to redo all the work he just did because somebody else has adjusted it. This kind of thing really has a lot of problems, and this is why we want to show everybody the cool stuff we're doing with 3D printed end of arms.
Yeah, there we go. That looks familiar there. That looks familiar.
Yeah. This is actually one of my favorite ones we've ever built, just because, man, it comes out so clean. So this actually picks 32 different parts out of an injection molding machine. So each of these suction cups is holding on to one part. The first thing when we kind of look at this, we notice that there's no rat nest of tubing. That's point number one for 3D printed. The way we do that, if you look, this is this center portion, this eye-shaped piece. This is an aluminum back plane or back plate that we kind of bolt our sections onto. So these sections are what are 3D printed.
Gotcha.
So if we jump over to this guy and do a little section view here, you can see that inside of the print, we've got these internal channels. I know you guys love when I send you over something like this because all the powder's got to be cleaned out of these.
Yeah, that is definitely one of our favorite attributes or characteristics of a part coming from Savage Automation is the time that we get to spend together as a family, huddled around the trash cans with zip ties and wires, clearing out all those channels of all the powder.
Yeah,
absolutely.
It's but what's definitely cool, I'll tell you what, sometimes we get it and we get to play with the wire a little further, you know, get out those corners and everything. So it's nice and clean. But it's worth it. All that work is worth it because what we get is basically a manifold. Mm-hmm. So when we plug in our vacuum line over here on the back, that connects us to this whole manifold. So all 8 of those suction cups are fed with just one single tube. So we don't have to worry about zip tying and organizing this mess of tube. It's all printed in. Another nice thing about this 3D printing is when we design this, we've got the CAD in front of us that shows where the parts are going to be. So in this case, this is an injection molding machine that we're taking parts out of. So we have the CAD model of this injection mold that shows us the spacing. So instead of being adjustable, we print this at the same spacing as the mold is. These suction cups are already in the right place. Nobody needs to adjust this. When we take the end of arm off and bring it back, it's going to be in the right place.
Yeah, that's really cool. And it goes to what you're saying. Like if you're setting something up for automation and you're using robotics to do what you need it to do, then having and utilizing the geometry that you already have in the computer of how that mold is going to operate, it only makes sense to have at least as many groupings or couplings like you have here. You have the 4 little groupings, and at least you're dialing in, you're eliminating variables from the situation, like you said, where you're going to come and set this machine up the way that your company operates. You're going to come and set this up, and then you're going to fly back to Utah. And the fewer things that the tool can have messed with after you leave it behind with the operators, the better.
Exactly. And it's going to repeat every time for them. Otherwise, we're wasting time. That technician time, sometimes in manufacturing, we imagine that that's free. As long as it's in-house, we're not paying for that. But really, that's delaying our next job, our next task, better 5S in the shop. Every minute a tech spends wasted on automation is really, undermining the point of automation. We're trying to take people's hands off of these processes. So the better we can design this end of arm tool, the better our automation is going to function, and the more we're going to have a hands-off manufacturing process.
Right on.
So we look at the back of this here, you can see we've got 4 nice clean tubes that only have to go right to our center quick disconnect here. It's easy to troubleshoot. All of us can look at this and easily see where the tubes go. We don't have to trace out a line. We don't have to figure it out. Everything's set up for us.
Yeah, simplicity is key right there, man. I mean, like you said, and then it also looks like, I wouldn't know. You may be able to elaborate a little bit on this here quickly at the end, but when you start reducing the tubing and all of the things that you have going into that, are you also able to reduce the overall profile of the end of arm tool so that maybe you can operate the tool in the mold a little bit quicker, not maybe have to open the mold up as far, anything like that?
Yeah, I mean, all of those things definitely apply. Not opening the mold as far as actually can reduce a lot of the cycle time, because you got to open the mold every single cycle. So let's say you're running a 30-second cycle, and now we have to open the mold a little bit less. Now we're running a 29-second cycle. Well, that multiplies every single cycle, right? Throughout the day, that's hours of saved time or hours of extra production. And speaking of speed, by also making this lighter, right? All these 3D printed sections have made us much lighter. We can now move our robot faster.
Nice.
So we wear out our robot a little bit slower because we're not putting as much strain on the servos. We're also running faster and getting more cycles in. There's a ton of benefits of doing it this way.
Very cool. Very cool. Well, cool, man. You got anything else to add on that one there? That's a pretty interesting tool, pretty simple design, pretty straightforward, and, seems to solve a few issues that you would have with traditional manufacturing,
Yeah, I just want to put the plug in for additive, right? This is a classic, awesome example for additive. We're trying to, as the technology evolves, find where does additive fit, what's it good for. This is a pure play on additive because we have a part that we're only going to make 3 or 4 of. We've got something that's a long-term solution, and it's a complex geometry. Those all play into the ballpark of additive.
Yep, absolutely. And then, the one last thing on the end there would be you have a digital twin. You have your digital file for down the road. If a tool crashes or something changes, boom, you can very quickly replicate exactly what you had. And, instead of going back down there and fine tuning that setup that you may have had in the device that you showed there previously. So
definitely, we get that, 9 o'clock at night call to Additive America. Hey, I got to have you print these parts quick. Then the customer's happy because 2 days later they've got it on their machine and running again.
Yeah, back and going. Yeah, definitely quicker than getting it back through the CNC machine, having the machine set back up for all the operations and all those things as well. So, yep.
Exactly.
Yep. Absolutely. Well, cool. That is episode 1 of Tool of the Week. I'm Zach Holcomb with Additive America. This is Richard Savage with Savage Automation. If you need any help, or you're looking for to learn more, or you're looking to maybe bring some automation design and stuff into your business, that would be Richard right there. If you're a guy like Richard out there, or you're someone else in working with robotics, automation, or EOATs, or any of those fun things, I love saying it that way. It just grinds Richard's gears. But if you're looking for any of those just printing opportunities where you've got your CAD and you're ready to go, we'd love to take care of you at Additive America. So that's savageautomation.com and additiveamerica.com. You can find myself and Richard all over LinkedIn, and that's pretty much the best way to get a hold of us. Appreciate it. We'll catch you on episode 2. Be on the lookout. Thank you for checking us out. Have a good day.